Hello, everyone. Thanks for joining us this afternoon or whatever time of the day it is where you are. I hope you've all been having a great conference so far. I want to welcome you to this session on data visualization for the database developer. Give me just a second here. There we go. My name is Rick Borup. I, since 1993, have owned and operated a company called Information Technology Associates. I work virtually 100% in Visual FoxPro and SQL Server. So that's kind of my background here. And I'm going to go ahead and turn off my camera so you all can see the slides a little bigger on your screens, hopefully. I wanted to spend a moment talking about why I titled this data visualization for the database developer. And the reason is that I think we as database developers tend to see the world in a very different way than our users do. You know, we spend a lot of time organizing our data into tables, and we spend a lot of time and effort thinking about what the columns should be and their sizes and their data types and so forth. We think about how the data tables are organized into our databases, whether it's Visual FoxPro, SQL Server, or whatever have you. When somebody wants to quote unquote see the data, we think in terms of creating select statements to pull data into a cursor, maybe for a report. And to us, frequently, seeing the data means seeing it on a report, as an example. Well, that's only a small part of it, and certainly perhaps not the main way that our users might want to see it, at least in some cases. So this session is about actually seeing the data. And here's our agenda. I want to spend a little time on human perception, how it works. We'll talk about the difference between data visualization and infographics, just briefly, because I want to know that you all can make that distinction. We'll spend the bulk of the session on creating visualizations. We'll talk about seeing the data from our user's point of view, choosing how to choose and what the choices are for the right kind of data, the graphic, and the tools that we have available to us to create visualizations. Then we'll talk a little bit about building and refining our visualizations. And we'll finish up in the last 15 minutes or so with what I think is a really fun segment of this presentation, lying with graphics. That kind of gets into how we can mislead or be misled with those graphics. So with that in mind, let's get right into it. I'm going to talk about human perception. Like most animals, humans are visual creatures. Of all of our senses, vision is the most dominant. It's how we get around. It's how we perceive threats. It's how we find food. It's how we recognize other people. There's a really interesting book called Brain Rules by Dr. John Medina. I'm going to reference several books during the session here, and all of them are on my bookshelf. And if you're interested in pursuing any of these, I can recommend all of these books to you. Anyway, he makes the point that vision trumps all other senses. Vision, in most animals, including us, of course, as humans, has two parts. There's the sensation, which is the physical stimulus entering the eyeball. You've all probably seen a drawing like this in your this particular one comes from the same material that is in the book. And the point is that if you are exposed to something that you're trying to learn and retain, and you only hear it, then 3 days later, you're going to remember 10% of it. If a picture or a visual component is added, then you will remember 65% of it. So that's a pretty huge difference. He goes on to make the point that not only are text and oral presentations less efficient than visual for retaining certain kinds of information, they are much less efficient. And a couple of things that I learned in reading this book is that we see words as lots of tiny pictures. You know, we all learn to read and we don't necessarily think about the mechanics of how we read, but what's going on is that we're seeing these words as tiny pictures. Right now, you may be trying to focus and make sense of those blurry pictures on the screen. Our brains are doing a lot of work when we read text or numbers. And he goes on to make the point that there really are no such things as words. We're going to stop and ponder the individual features of the letters, which our brains then can form into words. That's why reading text and numbers is less efficient, because biologically we've evolved to instantly see pictures, and we have to be taught how to read. A couple of corollaries to this is that we see what we expect to see. That's what makes, for example, proofreading so difficult. In the text on this sample agenda here, or minutes from the meeting, there's a typo. Now, you probably have spotted it because I told you there was one there, but on the second line, the word February is misspelled. That's very difficult to see, particularly because we have a context that already mentions a day and a month, March, and so forth. So we're thinking in terms of days and months, and when we see February, even though it's misspelled, we see what we expect to see. The flip side of that is that we do not see what we don't expect to see. This comes from a book called Now You See It, Simple as Visualization Techniques for Quantitative Analysis. Take a look at that rose, a picture of a beautiful red rose. Do you see anything unusual about it? You might have, because now I've kind of prompted you that there is something unusual. But if you didn't know it, how many of you saw the dolphin? You're just looking at the rose. Do you see the dolphin? Well, I'm going to guess probably not, at least not right away, because we don't expect to see a dolphin in a rose. So the implications of these points is that when we're doing data visualization, we can inadvertently obscure something, or we may need to highlight it in order to bring out what we're trying to get across. Let's spend a minute talking about the difference between infographics and data visualization. Infographics may or may not contain data visualizations. There's a site that kind of guides you through creating infographics. If you're interested, that's the link at the bottom. It's a combination of graphics and text, and they're very useful in their context, but they're not necessarily data visualizations. Here's one that conveys a lot of good information, but it's not a data visualization because there's no data. This one has a lot of data, but it's not really presented visually. If you look in the middle, there's a little cartoon picture of a car and a gas pump and a tree and so forth. That's not really data visualization. This is an infographic. This is a very nice and kind of a timely infographic. It charts the relative risk of various kinds of activities, going from low risk on the left to high risk on the right. I think the colors and the size of the circles is intended to convey another dimension of the increased risk, but it's not really data visualization. For one thing, there's no quantitative information being represented here. So those were infographics. Now let's talk about what data visualization is. Basically three kinds that I'd like to suggest that we sort of categorize as we're thinking about these things. So-called classic charts, pie charts, bar charts, column charts, and so forth, are intended to communicate meaning very quickly. If you have more complex data, you might want to create a complex visualization, not so much to convey the meaning quickly as to enable the viewer to explore the data. I'll have examples of all of these as we come along here in a There are four sets of data represented, each with two series, X and Y. The Roman numeral at the top identifies the four series of data. So Roman numeral 1, 2, 3, 4, and so forth. So take a minute to look at the numbers there and see if you notice anything. If you look at it for a few seconds, you might notice that the X-axis numbers are the same in the first three series. In the fourth, they're different, except all of them are 8s, but for 1. The Y-axis numbers, you don't really get a sense of what's going on. So you're not quickly going to get any particular meaning from this data just by looking at it. But if you chart the data on a scatter chart, this is what's coming up here, you immediately see the patterns. So look at the Roman numerals 1, 2, 3, 4. I'm going to back up and look at that previous slide. That's the numbers. Look at the chart of those. In number 1, you see that there's a progression somewhat of a scatter. Number 2 is clearly a curve. 3 is a straight line progression with an outlier. 4, everything is on the 8-unit point on the x-axis with one outlier. So how much more quickly do we get meaning out of those numbers by seeing them graphically than we did by just looking at the numbers? Moving on from simple to more complex charts, if you want to visualize data in a way that helps your user to explore it, then a more complex visualization is what you want to go for. And what I'm going to show you here is what I consider to be one of the best examples of a static complex visualization. This is a chart created in the mid-1800s showing the march of Napoleon's army on Moscow in 1812. There's a lot of information there. You can spend a long time looking at this and understanding, but even on a glance, as soon as you know what you're looking at, you can see some very dramatic information. The tan line moving from left in the Polish-Russian border to the right, upper right-hand corner at Moscow, illustrates the march during the invasion portion. The width or the height of that tan bar is the size of the army, starting at about 400,000 and diminishing fairly dramatically as it moves toward Moscow. The black line moving from the upper right to the lower left is the retreat, or the return, if you will, from Moscow back to the origin point. Again, the width of the bar showing the relative size of the army as it gets back and splitting off in a couple of cases to fight other battles, returning with about 10,000 out of an original 400,000 plus. Down at the bottom is a chart of the temperatures during the winter, showing the extreme cold that the troops were having to deal with. And of course, superimposed underneath, or the main portion of the graphic, is the geography, showing the various geographic points in a couple of rivers. So this is a complex visualization, but I think an extremely effective one. Now let's talk about animated visualizations, which show a change over time. I can't really show you the animation portion here. It just doesn't work to try and stream that and then stream it back out over the presentation here. But I'm, again, going to give you some references and some links so you can hopefully, if you're interested, go to the actual site and see the visualization or the animation for yourself. This one by Dr. Hans Rosling shows the evolution from 1968 into the 2000s of the life expectancy in Mexico versus the United States, correlated with the number of babies per woman. And it's a very interesting animation. Dr. Rosling is a preeminent expert in this field. He has a book called Factfulness, 10 Reasons Why We're Wrong About the World and Why Things Are Better Than You Think. Again, would recommend this as an excellent book. Dr. Rosling is very passionate about his subject and very well known and respected. Sadly, he passed away a couple of years ago, but the book is certainly available, and as is much of his work online. You'll see his passion for his subject if you view the animation. Here's another one from Bloomberg Business. There are actually many charts here. This is just one of them. And when you animate them, if you go to the online site and take a look, assuming it's still up, this was from 2015, the charts actually move as they go along from left to right. And they show several factors that are considered to be contributing to warming, to global warming, making the point that human factors are the most important. Finally, there's this one. On the right in the lower right-hand corner is the, it's almost gut-wrenching to see it, it's the casualties. And they increase from 0 at the beginning of the war to into the several hundreds of thousands, and the numbers continue to change as the battles unfold and the war progresses. It's probably the most well-done visualization I've ever seen. Again, if you get a chance to see it, I'd highly recommend it. So let's branch away from that. We're going to be spending most of our time with more simple graphics from now on. And we'll talk about seeing data from the user's point of view and the importance of trying to do that when we're thinking about how to extract the data and how to present it to our users. So just a couple of examples here. This one comes from the power company, showing the comparison for the last 6 months this year versus last year. So nothing fancy here, but again, this is from the user's point of view as the consumer of the utility, the gas, natural gas in this case, kind of interesting to see how the usage compared year over year. Probably no surprise, because you know when it's colder and when it's not so cold in any given month. Not much you can do with this looking forward, because you're going to heat your home, and how much gas you use is going to depend on how cold it is, but at least in part. But that's one example of presenting the data in a way that it makes sense to the user. Here's another one, a little more creative one, I think. This is a radial gauge from an ad for lendingtree.com. I think there's a lot going on here. I think it's really well done. First of all, the gauge has a start and a stop, bottom left and bottom right. Secondly, the colors kind of intuitively tell us that lower numbers in orange and yellow are probably a caution or a warning, or not as good. And then into the green on the right-hand side are getting better. And there's a tick mark at 681 showing what the relative position is to the whole scale. And then, of course, the number itself shows up in the middle. I think if you probably went to the site and drilled in, and you could see your own score perhaps indicated on a similar kind of graph. And finally, this one. This is from VerizonWireless.com. This was a snapshot of my plan some time ago when I first grabbed this screenshot. And it's a nice way of representing quickly, from my point of view as the user, how I'm doing on my usage. Now, of course, I have to know where I am in the month. Either I'm at the beginning of the month or in the middle or the end of the month. It would make a difference. But it shows the minutes used out of the total, the messages, and the data out of the total that I had available. And that number is then repeated in the center of the donut charts. And of course, the green coloring on the segment shows in a very quick way how much of my total I've used. So this is a nice visualization because it stands by itself even without the numbers. We can take away the numbers and it still makes sense. We can take away the numbers in the middle and it still makes sense in the terms of how close am I to my limits. In fact, if I was going to do this one this way, I would probably make it look like this. And with no numbers at all, this is still a nice data visualization. So again, back to the original, but this is a dashboard. And dashboards can be extremely useful to your customers in helping them to see changes and to project and make decisions going forward. Now let's talk about choosing the right data. This is an important part of creating a visualization. And in fact, this applies whether you're creating the visualization for your customer or whether you're making data available for them to create their own visualizations. A lot of my clients are very fond of Excel. Maybe yours are too. And sometimes they ask me to create data sets or to make an option in our application so that they can pull a data set to support a visualization. So choosing the right data is important. Here's some examples. Here we have a sales increase over last year of 10% for the widgets product. Well, that sounds pretty good. 10% increase, not too bad. But let's put it in context. If gadgets had a 50% increase and doodles had a 30% increase, then our 10% increase in widgets, the term average gets used in kind of a generic sense very frequently, but it can be very misleading. In this list of 9 numbers, which represent selling prices of homes, 189 is the median. It's the point at which there's an equal number of data points below and above. The mode, another metric, is the number which occurs the most frequently, but the average is way down here at 356,000 almost, also called the mean, of course. So the point of being careful with this is that if you are either presenting this information in a vacuum or perhaps being a consumer of this information, in other words, perhaps looking for a home in a particular neighborhood, and somebody tells you that the average price is $355,900, you might think, well, that's a little high for my budget, or maybe that's a little low for my budget. But in any case, it's not really a good representation of the actual available homes in the area. So just be careful when you're either presenting an average or when you're being told what an average is. Choosing the right graphic is as important as choosing the right kind of data. The pie chart is probably the simplest and the most frequently seen. It represents a proportion relative to a whole. Sometimes you can include the actual numbers and a legend to identify what they are. Many, many different ways of doing a pie chart, but again, good for showing proportions relative to the whole. I love this next slide. What is not represented could also be important. This is from Gar Reynolds. You remember Yoda in the Star Wars movies saying, "Do or do not. There is no try." And so Gar Reynolds, the author of the Presentation Zen book, again, highly recommended, created this graphic and posted it on Twitter at one point, showing that there is no try. I just thought this was a very creative data visualization. Column charts, or if they're sideways, they're called bar charts, are useful for creating or comparing across a set of data, not always from highest to lowest or lowest to highest, but that's kind of traditional. If you have two sets of data, you can put them side by side in a bar chart. That's a convenient way of comparing two different sets over the same products. Color can be used to highlight one particular item. In this case, average salary for Big Ten grads after 6 years. This is information is probably about 6 years old now. I chose to highlight Illinois just because that's where I live. Scatter charts, a couple of different ways to use them. If you have data with two variables, in other words, you have an X and a Y axis, you can create a scatter chart just with the points. You can add a line if there's a progression. This particular one is some hypothetical organization's number of members over a 5 or 6 year period. In the sense that a membership level represents a volume, we'll get there in a minute. Let me back up. If there's a trend, you can add a trend line. This is a linear regression that most tools, including Excel, can do for you. So it's a little different than just the line chart. The trend line shows the progression and tries to forecast where it's going. An area chart can be used to represent a volume. So if numbers of members, think of number of people in a room, for example, a volume chart is a nice way of showing that. There's an important thing about a volume chart, and we'll see this again as we get going a little later on. You always should include the 0 point in an area chart, and I'll have an example of why that's important when we get to the lying with graphics section. A stacked area chart is useful if you have 2 or more series of data. In this case, we have students and non-students, or if you will, adults, and you can use a stacked area chart to show the relative proportion of the two. So that's a nice visualization as well. If you have 3 variables, there's a thing called a bubble chart, which this is the data that's going to feed the next example. We have marketing expense is one variable over these 7 products. We have total sales, and we have gross profit for each product. Now you can look at those numbers, and you'd have to spend a little bit of time kind of ferreting out the actual meaning, but let's put them on a bubble chart. On the x-axis, we have the direct marketing expense. On the y-axis, we have the total sales, and the bubbles on the chart represent the gross profit. The area of the bubbles, not the diameter, but the area of the bubbles is proportionate to the gross profit. They sit on the X, the center of each bubble sits on the X. The left y-axis being the number of homes and the right y-axis being the average price per home superimposed on it. Waterfall chart is a pretty cool way to show an increase or a decrease from some starting value. This one tracks the progression from gross revenue on the far left to net income on the bottom right. Each orange bar shows a reduction, and the data points, data labels show the actual dollar amount, and then the gray bars are a stopping point along the way. So we move from gross revenue to net revenue, down to gross income, down to operating income, and finally, after we pay our taxes, we have a net income. So that's called a waterfall chart. Box and whisker charts are useful for showing a distribution from across a minimum and maximum with a concentration in the middle. This particular one came from the website shown down below. It doesn't have any particular context, but it illustrates how they're constructed. Now let's talk about choosing a tool for creating your graphics. And this might be a tool that you yourself use, or it might be something that you advise your customers that they could use. If you're working in FoxPro, Fox Charts is the only one that I know of that's pure FoxPro. I know this, that Tamara mentioned this in her session in the last segment of our conference today. And from the comments that I saw going by in the chat session, several people are actually using Fox Charts, and that's great. It's now on GitHub. It was originally on CodePlex, but like all of those projects has moved over to GitHub. The link is at the bottom. Just a couple of quick examples of the kinds of things that can be done in Fox Charts. Again, I know from the comments that showed up on Tamara's session that at least one person, I'm sure many more, developers are using this in their applications. So that's really interesting to know, and I look forward to learning more about how it's being used. Here's a line graph, a series of line graphs created by Fox Chart. Excel is really good at creating charts. In fact, starting in 2016, it added a whole bunch of new ones. Those are highlighted in the red box to the lower left, including some that we've just seen. For example, the box and whisker, the waterfall, the combo chart, and several others. So Excel is kind of maybe your go-to product if you're not using Fox Charts. I find, again, that it's a go-to product for many of my clients, and they don't necessarily want me to create the visualization so much as they want me to create the data that can then feed the visualization that they can massage and modify and create to their own specifications. Did you know you can create data visualizations directly in PowerPoint? Well, you can, and this is one quick and simple example of one that I created in PowerPoint just to show that it can be done. I need to mention Power BI, BI for Business Intelligence. I did a whole session on this, I think 5 years ago, and there's a white paper on my website about it. This was a relatively new product in 2014, 2015, that area. It has evolved immensely since that period of time. It's got a very active user community. It's very strongly supported by Microsoft. It has continued to evolve. I think there are new releases essentially monthly with new features being added all the time. You can download it for free. There's more than one version, but one of them is a desktop version, which you can download for free. If you do that, it looks like this on your desktop. And basically, you simply add a data source, which could be Excel, could be SQL Server, could be a CSV file, several other types of data, including ODBC, which makes it possible to access visual FoxPro data via ODBC. And this next slide is a data visualization that I created in FoxPro using ODBC to access the Northwind database. You remember early on in the presentation I talked about a report as one way to see data. That was number of customers by country in the Northwind database. Here's a visualization of those same numbers created in Power BI. So that's a very powerful tool that you can use. And again, the desktop version can be used for free. Finally, I want to mention Tableau Software. I have not used this. I think it's a more high-end product. The reason I'm mentioning it is that in many of the books that I've have put together as part of the research for this presentation, I came across references to Tableau Software, that some of the graphics that were being shown in these books were created by Tableau Software. So I wanted to mention it. This is, I believe, a current screenshot of their website. Thinking in this case primarily about the simple kinds of charts, the classic charts, where you're trying to make a point quickly. So how do you convey only what's essential? Well, you just have a starting point, whatever that starting point is, and you study it a little bit and you eliminate things that aren't necessary, that abstract from the whole. In other words, just simplify and get it down to the essence. So to illustrate this, I created this entirely fictional survey of America's favorite cookies. I put chocolate chip at the top, followed by oatmeal raisin, peanut butter, and so on down, with several trailing and small percentages near the bottom, just to create some kind of a thing that we can represent graphically. So let's create a hypothetical or a pie chart of this hypothetical data. One way to do it might look like this. If the percentages are important, then add them to the chart. In this case, there are so many segments on the pie chart that the last ones got pretty small, and of course the percentage numbers have to be shown externally. By the way, it's traditional with pie charts to start at the 12 o'clock position and go from the largest segment to the smallest going clockwise. So 35% going from 12 o'clock to about 4 o'clock, 20%, 15%, and so on clockwise around the pie. It's not necessary to do that, but that is kind of the rule of thumb for creating these things. One problem with this chart is that there isn't enough space for all the legends. The colors correspond to the ones that can be shown, but the legend isn't complete. Here's another way to do it. This is a little bit simpler. We're still showing the numbers in there, but we've actually compressed the several lowest ones into just an other category. So if it's not important to show them individually, this would be a way to simplify the presentation. Finally, you could make it what I consider to be a little prettier. If the numbers themselves aren't that important, you could remove them and just show the graph like this. On the other hand, if the detail of the smaller segments is important, you can use what's called a pie in pie, or a breakout pie chart that takes the other category and breaks it out. Now, when I did this, the 35% range no longer appeared in the upper right. I think that's just because that's how it had to be done. I think I did this in Excel. So this is one way to do it, or we could actually make some changes to where the numbers are, whether the numbers show at all. Here's another example. Back to our annual average salary for Big Ten graduates. This one starts with pretty much everything under the sun on it. And it's really kind of overdone, and what's there obscures the actual meaning that we're trying to get across. We don't need the data labels, do we? The ones across the top, first of all, they're stepping on each other, so you can't really read them. Secondly, there's a y-axis scale that shows what the numbers are, so let's get rid of those. There's no trend here, so why do we have a trend line? Let's get rid of that. We don't need the legend on the right. The x-axis has the identifies which schools we're talking about, so let's get rid of that. We don't need the legend on the left where it says average salary, because it says average salary at the top, so we can get rid of that. Similarly, we get rid of university at the bottom because we know that there are Big Ten universities. So we're down to this, which is about as simple as we can get. One more step we might take is, do we need the y-axis lines, the horizontal lines? Probably not. We're not too concerned about the actual numbers. We're more concerned about the trend, or not the trend, but the range, if you will, from highest to lowest. And again, I chose arbitrarily to highlight Illinois with an orange color there. So that was one very simple way of giving some thought to how we could simplify our graphic to get our point across the most quickly. Again, looking at the before and after, if our point is to show only the relative size of the average salaries and to highlight the Illinois one, the before picture just invites unnecessary scrutiny, looking at all the different things that are on there, where the one on the right, I think, is the better representation of what we're trying to show. So now we're going to spend about 15 minutes or so on what I call lying with graphics. And I call it that because it was prompted by this. Maybe more importantly, how to determine if you are being misled when you're viewing a graphic that was created by somebody else. You probably heard the old quotation, and when I looked it up, I found that it was attributed to various different people. One of them was by Mark Twain. In any case, while it's true there are three kinds of lies, including statistics, there are also, you can include graphics in place of statistics in that. So let's move on, and we're going to introduce our guide for this section is a little detective named Sam Sleuth, and he's going to take us through 4 or 5 cases, and we're going to find out what's going on and why we're being misled or why we're misleading. So the first one is the case of the missing zero. And to illustrate this, I chose the Dow Jones Industrials average closing values from mid-June through mid-July of 2015. This is back from when I first put this session together. Side note, it's kind of interesting to see that 6 years later, almost 6 years later, those numbers are roughly twice now what they were back then. Not quite twice, but pretty darn close. Interesting how much that's grown in just 6 years. In any case, that's our numbers. A date and a closing value on each of those dates, Monday through Friday, of course. So here it is on a simple line chart, starting with June 18th on the left on the x-axis and July 17th on the right, the y-axis moving up and down as those numbers varied. So that gives us kind of an indication of what the change was over that 1 month period. But if we have a portfolio that is invested in stocks that somewhat track the Dow Jones Industrial Average, we would think of the pot of money that we have invested as a volume. So we could construct a volume chart or an area chart just by filling in the area under the curve. And that presents a kind of a scary looking picture, doesn't it? This is a pretty volatile market. We might be uncomfortable if we were invested in this market, or we might be unwilling to invest if we looked at this historical and we were thinking about investing in this market. But what's wrong with this picture? Well, what's wrong is the missing zero. The bottom of the y-axis in this chart, and this is where it's very important as an area chart, is not zero. So let's make it zero and see what happens. Now it's zero, and look at the variation across the top. That looks not so much like a jagged mountain peak as it does like gentle waves, perhaps on a body of water. So that market is not really as volatile as it was made to appear when we had a missing zero on the earlier graph. Using the same data, we can look at the case of the selective range. We can choose to paint a different picture depending on what data we choose to include. So here's the original graph again, showing all data points for the month period. And I'm going to segment that into 3 parts. And I kind of chose them arbitrarily. You can probably see why I chose what I did. So they're roughly 10 days each, not exactly. And then we're going to chart each one of those individually. So we're being selective about our data. If we look only at that first segment, that market looks like it's really taking a nosedive. We might want to get the heck out and sell. If we look only at the middle segment, pretty much steady, a little bit of a drop there at the end, but maybe that's a hold on and see what happens type of situation. If we look only at the third, that's rising pretty steeply. Again, all 3 of those are distorted because we're not starting at zero, but that's not the point for this exercise. The point for this exercise is that by segmenting the data, we can choose to paint whatever picture we want. Now, the entire period, June 18th to July 17th, we end up about back where we started, but that also obviously is an arbitrary choice of range. I mean, we might look at 6 months, we might look at a year, we might look at 5 years. It would depend entirely on what picture we're trying to paint and on what decisions we're trying to make, if we're a long-term investor or short-term investor or whatever. So segmenting our data can really create a different picture. The third example is the case of the unequal base. So Bob looks at this and says a 45% increase in hardware and only a 2% increase in salaries. Says that some of that 45% ought to be going to me. I deserve a raise. So he sets out to create a data visualization, a graph, to make his point. And first of all, he moves the hardware up to the top so it'll show up on the left in his chart. And then he creates a chart that looks like this and gives it a title saying, this company is prioritizing things over people. Look at the size of that increase in hardware compared to the size of the increase in salaries and the rest of them. That's just really out of line. I deserve a raise. What's wrong with the picture? Well, you know what's wrong with the picture because I told you when we started, it's an unequal base comparison. So Bob takes this to his manager and shows it to her, and she says, well, I immediately see what the problem is. The problem is that you're looking at an unequal base. The base for the increase in hardware is $10,000. The base for the increase in salaries is $500,000. So let's make this a little better representation. Let's use an equal base, either the 2020 or the 2021 total, and let's look at the percent of total represented by the expense in each of those categories. And if we do that, hardware has only 2% of the total, salaries has 75%, and there's a chart that better represents what's really going on. You could also perhaps do this as a pie chart showing 75%. So this company clearly prioritizes people and invests most of its resources in paying for people, paying good people to do good work, hardware being a very small percent. So the fact that it's spending $4,500 to buy a couple of new high-end laptops in 2021 is not really significant in the overall context of the budget for this particular company. So that was the case of the unequal base. Along the same lines, where percentages are involved, is our next case, the case of the percentage increase. This one, I subtitled, "You Can Fool Some of the People Some of the Time." This one came from an actual example that occurred about 10 or 11 years ago in the state of Illinois. And as a resident and a taxpayer in the state of Illinois, this one was important. Illinois has a flat tax personal income tax rate. In 2010, that rate was 3%. It was proposed that it be raised to 5% for 2011. So there's the difference. And the people who wanted to sell the increase, who supported the increase, some of them said, well, that's a 2% increase, right? From 3% to 5%, that's a 2% increase. That's not very much. Nobody can complain about a 2% increase. Well, guess what? You all know, of course, that that's not really a 2% increase. Let's do the math. 5 minus 3 over 3 times 100 is 2 over 3 times 100 is 0.67 over 100. That's actually a 67% increase, isn't it? That's obvious when you stop and think about it. But if all you see is a news report that says the state legislature is proposing a 2% increase in the personal income tax, you might just let that slide thinking, oh, that's not very much. So it pays to dig a little bit behind the scenes. Finally, the case of the implied volume. This one's going to involve bubble charts. And the operating concept here is that the area of the bubbles, remember the circles on our bubble charts? And what's important there is the area of the circle, not the diameter or radius of the circle. Back when I was first putting this together, I picked up a copy of Consumer Reports, a very reputable publication, which I read from time to time. And I happened, at the time I was writing the first edition of this session, to see this particular report. It's a little bit thick here. Give me just a minute to describe what you're seeing. This compares average premiums for an adult single driver, this is in the state of Florida, with excellent, good, or poor credit. Those are the first three numbers going down the right-hand side and the first three circles or bubbles corresponding to them, compared to the average insurance premium for an excellent credit, a driver with excellent credit, but a DUI, a drunk driving conviction. That's the bottom number in the bottom circle. So I was just curious. I don't think Consumer Reports certainly set out to be misleading. I didn't have that in mind at all when I started. I still don't, but I was curious how they did it. So I went and I measured the diameter of the real difference is 122%, 272%, and 161%, where the perceived difference based on the size of the area of those circles is much greater. And if you don't believe that it's actually 6 times as much, there's a comparison as displayed on the left, the corrected scale on the right. And you can see I took the excellent credit circle in the upper left and created 6 little circles of the same size, and to show that they pretty much fit in the poor credit one, when the real difference is less than 3 times, not greater than 6 times. So again, this was just an arbitrary exercise. Again, I was just curious how it was done. I don't know how Consumer Reports did it. I certainly don't think they set out to mislead anybody. There may be other ways of presenting bubbles like this, maybe other factors going on behind the scenes that I'm not aware of. But it was an interesting exercise and kind of showed how you could take a deeper look at something and maybe question a little bit how it was done. So that wraps us up. I know we're not quite at the end of our session time, so we'll have time for questions, and there also is going to be a Q&A session afterwards here. But let me finish up by summarizing that we learned that humans are visual creatures and that we are built biologically to comprehend images much faster than we can comprehend numbers or text, that it takes a lot of brain work to read numbers or text versus seeing an image, especially if we want to grasp something quickly, that we can comprehend an image much, much faster than we can comprehend the same information by reading a row of numbers or rows of numbers or by reading a paragraph or paragraph of texts. We learned that good data visualizations are intended to convey meaning quickly, and that there are other types of visualizations, complex and animated, that are excellent for different purposes, but also all of them, whichever kind you use, are good at conveying the information more quickly than just describing it visually or by numbers. We talked about choosing the right data, the right kind of graphic, and the right tool for the job. And finally, we finished up with a section on how to avoid unintentionally misleading your audience or being misled yourself if you're the consumer of a graphic. Please do fill out your evals. They're important. We do read them, and hopefully they help us improve our presentations for the next time around. I'll leave my contact information up here for just a moment as we sign off. Again, everything I presented here today is in the white paper by and large. The slides have evolved a little bit since the paper was submitted, but by and large, you'll find all of the same information in the white paper. Thank you for attending today. I appreciate your attention. I hope you're having a great conference and a great rest of the day. One more session to go. Thanks to Rick, Doug, and Tamar and Geek Gatherings for putting all of this together. Thanks to Rick Schumer for being the producer of this segment today. And I'll go ahead and leave the stage, and we'll turn it back over to the organizers. Thank you.